6.7. Our essential question: how do you recognize an exponential or a logarithmic model so that you can make predictions? So on the first sheet, exploration 1, recognizing different types of models. Match each type of model with the appropriate scatter plot. Use a regression program to find a model that fits the scatter plot. So we've done regression. We put our data in. We look at the different types of plots and see which it represents best. The model names are linear positive slope, linear negative slope. You should be able to recognize those two right off the bat. Quadratic, cubic, exponential, and logarithmic. So take a few minutes and see if you can recognize what types these are. Example 1, finding an exponential model. A store sells trampolines. The table shows the numbers of Y trampolines sold during the X year that the store has been open. Write a function that models the data. So we are being asked to find an exponential model. So we need our calculators. We are going to hit stat. We're going to hit enter. And then we're going to enter the data. So I have data in here. I'm going to go up to L2, hit clear and enter, over to L1, hit clear and enter, and it takes out the previous points that are in there. So I have 1, 2, 3, 4, 5, 6, 7. Make sure you've entered in the correct data. In L2 is the number of trampolines, so 12, 16, 25, 36, 50, 67, and 96. So I have 7 pieces of data on the left, 7 pieces of data on the right. I'm kind of giving it a quick check to make sure that I've put in the correct pieces of data. 16, 25, 36, 50, 67, 96. Okay. Next, I'm going to check my window. So if I want to look at this, I have a good window. So my largest X value is 7. My largest Y value is 96. So I'm going to enter 10 and 100. And maybe do an Y scale of 5. Hit graph. So there's my scatter plot. So this looks like an exponential model. So we window, and then we changed our parameters within the window to fit our X and Y data. All right, so the next thing we want to do is find the actual equation. So to find the equation, stat, arrow over to calc, and we are looking for exponential. There's exponential regression, hit enter, and for me I have to hit enter twice. I feel like for some of you, you have to hit enter more. So y equals a times b to the x is what our form looks like. And with this particular data, it's y equals 8.46 times 1.42 to the x. So we were asked to write a function that models the data, and we've done that. So this is our function. And when we graph it, it looks like it fits pretty well. Example 2, finding a logarithmic model. So we need to do something a little bit different here. This one's asking us to find a logarithmic model. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, which is 1.033227 kilograms per square centimeter. The table shows the pressure P in atmospheres at selected altitudes in kilometers. Use a graphing calculator to find a logarithmic model of the form H equals A plus B times the natural log of P that represents the data. Estimate the altitude when the pressure is 0.75 atmosphere. So we need to do two things. We need to find a logarithmic model, and then we need to estimate the altitude when P is at 0.75. So H equals, so that means that this is Y. H equals A plus B times the natural log of P. So this is our X. So now we need to stat and enter and enter the new data. So clear. So I have 1.55, 0.25, 0.12, 0.06, 0.02. On my Y, I have 0, 5, 10, 15, 20, 25. I have the same number of data pieces, 1.55, 0.25, 0.12, 0.06, 0.02, 0, 5, 10, 15, 20, 25. Okay, now I'm going to go to my window, like I did in the previous problem. This is my X. My largest X value is 1, and I have decimals here, so I might want to consider changing my X scale to 0.1. My Y max is 25. I will do 30 and maybe do a Y scale of 2. Let's graph it. That's what it looks like. So it's coming down. So now we need to write an equation. So to find the equation, stat, calc, and we are trying to find the natural log. So natural log regression. Hit enter and enter twice. For me, yours might be slightly different. So this is the form that we're supposed to take. Y equals A plus B, natural log of X. So it looks similar to what we're asked to do here. These are our values. Y equals 0.86 plus negative 6.45 natural log of X. So I'm going to, I've come up with the equation. Now we need to estimate the altitude when the pressure is 0.75 atmospheres. So I'm going to hit Y equals 0.86 plus negative 6.45 natural log of X. Graph it. It's going through the points, which is what we want. And I'm going to hit trace, arrow over, and then I'm going to type in 0.75, or not. trace. .75, and at 0.75, the altitude is approximately 2.72, and I'm going to get kilometers.